This is a very common style of multi-socket wall plate that seems to be appearing on eBay these days. I should mention that this one came with a nice big divot off the edge. I'm not sure if that happened during shipping or if it's during their storage. But the gold coloured plate in the front, I have done a high voltage test on this. I've done a 1000 volt test and to the edge, and it is completely non-conductive. It must be just a sort of iridescent pigment that is not conductive. That's a good result. The socket is designed to accommodate a whole selection of different standards of plugs, plus it's also got two USB outlets with a combined current supposedly of 2100 milliamp. We should test with the tester, we'll see what it goes up to. The shuttering, it does have shutters, which is quite good on both this pair of holes and the traditional sort of square pin socket holes down here, but it's quite easy just to poke something past that. And in Britain we have this fairly safe socket arrangement whereby normally the shutters, you can't just defeat them, you can't just prise them open. You have to generally either push something in both the holes at once, or in the case of the proper plug insertion, the earth pin is longer, so it actually pushes down a little catch in here, and when it pushes that catch down, I'll have to use this to push it down, it unlocks the sockets down below and lets you the other pins go in. It's a very safe system. It's a nice chunky robust thing. This is definitely designed for use of the British system because this is what we call a standard one gang sort of plate. It's for the standard Patras box, and it has the specific hole spacing, and it does match up to the hole spacing on the back of this. So I've already done some polarity checks. It is the correct polarity. I'll plug it in fact. Let's plug it in right now, and I'll keep my fingers away from the connections in the back. So if I plug into the USB outlet here, I'm getting a quite unusually low voltage, about 4.5, say about 4.6 volts. And when I plug a load into that of about 1 amp, it goes up slightly and it passes, let's see what current it's going to pass, 900 milliamps, which is good. And if I switch that to the other setting, it goes up to 1.76 amps, and at this point it should really be drawing about 2 amps. And the voltage also rises up slightly, but not quite going up to the full 5 volts. So I don't think it's a very well regulated supply, but it can supply modest amounts of current and doesn't seem to go, well so far, doesn't seem to go above the 5 volts. So let's open it up and take a look inside and see what the circuitry is like and the general construction. In fact, you know what, I may actually just pop those wires out the back. I've unplugged it. Wasn't overly thrilled when I was terminating this, it didn't feel pleasant, but we'll take a look inside and we'll see what it looks like. It might just be me being a bit fussy. It's also notable there is just a single earth connection. You'd have to either loop off the back, if you're using a metal box, loop off the back of the metal box into this earth terminal, or loop another wire out this terminal onto that box. So I'll just put this out of the way. And to open this, guess just prise off like that. Okay. So there's the front plate comes off to reveal the two mounting holes. Oh, that's it screwed now. I have actually just pushed that in permanently. That's not good. Oh no, it's fine. It was popping down. Oh, all the springs have just popped out. So they're the shutter plates. They are just spring-loaded ramps, fundamentally, so that as the pins are pushed in, it will retract. I suppose it will stop casual, lightweight objects being pushed in, but a persistent child with a knitting needle, it won't really do the biz. Having said that, these things are to be encouraged, because how many kids poked knitting needles into sockets and then latterly pursued a career in electrical engineering just because they were awed at the force of electricity that blew them across the room? That does actually happen. Same with the pyrotechnics industry. Kids who have huge pyrotechnic incidents when they're young often go into careers in that industry. So, the construction of this, let's see if I can get that Alright, that just lifts out. Right, that is the construction I thought it was going to be. I noticed when I was tightening it up that there was these little tangs going into the screw receptacles at the back. Can I get that out completely, or is that just going to... Oh, that should actually just slide right down, shouldn't it? Oh, I've just caused a mini avalanche on the floor. Not to worry. Let's see if I can... There it goes. Yeah. It's these brassy coloured... I say brassy coloured. For some reason it doesn't look quite right brass colour. And it attracts to a magnet. So these gold coloured steel contacts, which are pretending to be brass, when you put the wire in, it actually just grips this at the back, and that's what makes the connection onto the internal circuitry. And this is not generously sized. I take it that's not just copper coloured steel, is it? That is non-magnetic this time, so I think that is actually a copper alloy. Not sure. I would rate these for... I could just be being a bit pessimistic, but I'm not sure I'd rate these for the 13 amps. It just doesn't look generous, but you know, I might just be being pessimistic as I usually am. I like to see things generously rated. I wonder how these metal contacts will malform over time. They seem quite rigid. That's good. Yeah. So here's the USB socket, the power supply. So let's can we get this out? No, I'll just leave it like that. And it's got the mains going in, goes through a fusible resistor rated 2.2 ohms, red, gold, 2, and then divide by 10 for the gold. Separation. Where it comes closest, they have put a little separation slot here, but it does pass quite close here as well to the mains side, and that's just over a millimetre, so not really what I'd call up to British standards, but actually by Chinese import standards it's not that bad. The IC, let's see, we've got the incoming supply going to that fat capacitor, 400 volt 10 microfarad, which is quite generous. Bridge rectifier, little looks like a metal oxide varistor. Oh no, I'm talking crap. That's the class Y1 decoupling capacitor from the low voltage side to the mains side. Quite a small one, but then again it's not a high value. Then we've got the output smoothing capacitor. We've got these heat sinks. They're just glued onto the top of diodes. And they've got 2 diodes. Are the 2 diodes just in parallel? I shall check that out. Quite short USB sockets. The chip is I shall see if I can get a data sheet because it does have text. PN8359. PN8359. You know what? I'm going to check this up, and I'm also going to take a picture of this and zoom into it just to take a closer look at it, and we'll assess whether you think it's actually got enough separation. So I'm back in a moment. So here's what we've got. The PN8359 is a very standard chip, and it relies purely on primary side sensing. It doesn't have any feedback from the secondary to regulate that voltage, which is why it was just a wee bit up and down. And it has the fairly typical circuitry you'd expect of one of these things. Let me just show you the circuit board itself. So it starts off with the mains come in, and in this case it comes in here, it goes through this 2.2 ohm resistor, goes through this bridge rectifier here, and charges this capacitor, and that's effectively the bridge rectifier there, and this is the capacitor here, and that gives the supply to the power to the chip. The chip, should I say, that actually gives the supply to the circuitry for the whole circuit on that side, including the transformer. The chip itself has its own little power supply, namely this capacitor here and a diode here. And what normally happens is when the chip's running, this extra winding it's almost like an extra secondary winding, just acts to power this chip, and that's all it does. And it does that via this diode charging that capacitor. But to start up initially, some current, because the transformer isn't running initially, some current flows through the primary winding, and it trickle charges that capacitor via a current limiting, probably just a resistive network inside the chip, until the voltage in the capacitor is high enough, and then when it's high enough, it then runs the primary, and that then starts generating the current that will sustain it. So that's why when you turn something like this on, there's a small delay before it starts up, and also why when they're overloaded or something's going wrong, they tend to just fire in pulses. So in this case, there's an extra winding on this transformer, there's the diode, there's the capacitor, and that's what's powering that chip itself. The chip has a current sense which detects the current flowing through the coil, through the switching component here, and then down to the negative rail. And that's these two resistors here. They've got two resistors in parallel so that they can fine tune it. So one of them is 1.4 ohm and one of them is 1.3 ohm. We've got various support resistors here which correlate to the circuitry over here, the feedback circuitry, which has a tap from the, it uses the bootstrap winding also for feedback. And the snubber network, it's shown a snubber here, you can see one of the components is under the transformer, but all the components, diode, a resistor and a capacitor underneath, and that's designed to take the spike off the transistor in here when it turns off after it's driven this transformer, it's put a full magnetic charge into it, so to speak. When it turns off, that little circuit just stops any sharp transient from damaging the transistor in the circuit. The output, it's quite odd. At this side of the circuit board, we've got these thick solder pads underneath. And what it's actually doing, the output, is instead of using one diode like this, they've taken that out and they've put one diode that direction, one diode that direction, and then they've combed them together and then gone to the capacitor. And that's just purely to split the load between the two diodes. But they've obviously thought maybe they'll get off with using these large solder pads to help with heat dissipation, but laterally, these two diodes, they've glued a small heatsink onto the top of them just to actually help dissipate the heat. So they've used this sort of white goop and they've just stuck that heatsink on. The back of the circuit board, is there anything else worth mentioning on this side? Not really. Let me think, is there anything worth mentioning here? There are what looks like resistor networks, but having said that, there probably are resistor networks to set a voltage in the pin to allow the devices that are being charged to detect how much current they can draw, because it can supply theoretically about 2 amps out one socket. The middle pins are shunted together though, but there are a couple of facilities for resistive networks. They've left their options open here, and that's these resistors here. But there are unpopulated positions. It's obviously just for sort of fine tuning it. I'm guessing that resistor there might have been just a slight load resistor, but they've not used it. No LED. That's a bit odd. You'd think they'd have just stuck an LED in. The back of the circuit board. So it has an attempt at tracking separation here, sort of anti-creepage and tracking, but then it's got this bit here, and you know what, they could have just added a bit there just to try and sort of, because you know this space is kind of okay-ish, it's not great, but it's better than average. It's starting to get near the sort of 3mm mark, but this, it drops down to barely over a millimetre, if that, particularly at these points here, and that is effectively the main side of the circuitry. It's one side of the DC, and it's in the vicinity of the negative, the casings of the appliances connected via the USB sockets. So it's a bit disappointing that, you know, they put a wee slot in there, but they didn't actually put one here. I wonder why they did that. It would have really helped with the isolation. Now, one other thing we're going to do then is do a wee high voltage test on this. So I'm going to grab my slightly patronisingly named socket and C high voltage tester, which is, there it is. And I'm going to do a high voltage test from the primary side of the transformer to the secondary side. So let's turn this on. Yeah, they called it socket and C. What a patronising name. It just, you know, you spend a fortune on test equipment and they give it weird names. Having said that, I quite like these little testers. Test volts, let's put it right up to 1000 volts. We'll leave it in certification mode, which does a longer test. I think that should do fine. So let's test from, I know the middle pin is connected to the output of the transformer, so let's go to there, and let's go to here. Try and hold these on without actually getting my fingers in the way of 1000 volts. Not high current, but it would hurt. And test. I heard a slight zip from that. I wonder what that was. It's showing 999 megohms. It's showing open circuit. Let's try a different way around, just out of interest. Noting that I could be charging up capacitors or anything. I'm not like to be charging up capacitors. Let's try that test again. Yeah, I definitely heard a quick zit, as if something was charging up. Yeah, odd. But it does seem to be passing its high voltage test. Oh, I should be calibrating this, shouldn't I? You know what? There's this thing in Britain that you're supposed to send your meters away and get them calibrated every year, which is a load of bunk. It doesn't say anything about that in the electrical regulations whatsoever, but there's a bit of an industry about it. And what happens is you send your meter away and they just test it. They say, for instance, they put it across a 1 megohm resistor and test to see if it displays 1 megohm. You know what? I'm going to go and grab a 1 megohm resistor. Right, a 1 megohm resistor. I think that's a half watt. Is that 1 watt? It's carbon film, it's probably half watt. Let's see what that comes out at. I don't think that resistor will be rated for 1000 volts though. Should be interesting. Let's see what happens. In fact, let's test it at... yeah, it's not rated for that. So let's go down to the 500 volt test, which is the normal insulation test, and let's test this 1 megohm resistor and see what we get. Spot on, 1 megohm. So yes, instead of sending your meter away to calibrate it, you can get a standard 1 megohm resistor and you can test it yourself. So yeah, so final conclusions about this. Would I install this in my own house? You guys already know the answer to that, because a couple of things I don't like about it. I don't like the fact they've used steel contacts at the back, although ultimately they're just acting as a support structure to go onto these contacts here. It's got that universal flimsy, you know, put the wrong plug in, or it's going to open the contacts a wee bit wider and not going to make great connection. I just don't like these multi sort of form sockets. They're not compliant with anything, are they really? But that might just be me being fussy and pernickety. I'd rather use an adapter, even if it was something horrific like this, just for a temporary connection. I also don't like leaving active circuitry like this just permanently connected. I'm not sure how flame retardant this plastic would be. Would it support flame? Now that would be a test, wouldn't it? Is it a lighter? Yes, I have a lighter. I wasn't planning on doing this test, but hey, you know what? Let's do the test. It's puffing up. It's making lots of smoke. For a moment there I thought it was kind of self-extinguishing. I'm not sure about that. What do you reckon? it kind of burnt for a modest length of time. So let's say not guaranteed to be 100% self-extinguishing plastic. Was that an unfair test? Let me know in the comments below if you think that was an unfair test. This though has not got good enough separation. It's active all the time. It doesn't put out a regulated 5-volt supply. Would I put it on my own wall in the house? No, I wouldn't. Very stylish, but not really my thing. But interesting nonetheless to take a look inside. And I'm not going to be too harsh on this module. It doesn't put out 5 volts. It doesn't monitor the voltage, but it still looks like they've put some thought into. They've used a decent chip. It seems to have the modest electrical separation of swarm out. It's past its 1000 volt test. That's no great deal because I think they've tested normally at higher voltage. It's got poor separation, but it does. They've kind of made an effort with the cooling and stuff like that. They've intended it to drive the best part of about 2 amps. And certainly when I plugged the tester in, it was drawing about 1.75 amps, even though because it was below the 5 volt threshold, the level that it should have been aiming for. But so that side of it, it's kind of okay, but still, as I say, I wouldn't actually use one of these myself. I don't trust something like this permanently hooked into the wiring of the house. For fairness, I have had a few goes at lighting this, and you can make it flare up to a modest degree, but it does appear to be self-extinguishing. It's only dropped one blob of plastic, which also self-extinguished. But it burns for a bit, and then it self-extinguishes. It puffs up and then it sort of blows out. So, for fairness sake, I'm going to say that yes, the plastic probably is self-extinguishing. Let's try this. The front plate would also be a fairly critical component here. Guessing it's probably made of the same plastic. It's also puffing up and producing lots of black smoke and strong smells and wispy floaty things. But it also seems to be self-extinguishing. It's not really supporting combustion easily. So just for fairness, I just thought I'd mention that, that it does actually appear to be fairly decent plastic in that regard.